Hello everyone, I am Vipin Kumar and I welcome you all to Gate Academy 2.0. So in the last session, we have done few questions from Gate, right? Uh, Let me just 1 second. Let me check if my audio is clear. Okay, so audio is clear, and now let us. Yeah. So Nitish Kumar is asking, sir, I am from chemical. Should I attend the session? Yes, of course you should. This is heat transfer. It is same in chemical and mechanical. Even I have taught heat transfer in chemical to chemical students as well. So you can attend this session. Your syllabus is almost same for heat transfer. Of course, you have a separate section for mass transfer that is not covered here. Okay. Now, so in the last session, day before yesterday, I think on Saturday, we did few questions on gate that was focused on bark. So now today we are going to focus again few questions of gate, and then we will move to ISRO. Okay. Again, I should tell you that gate questions are important because they cover on more than one concept for your exams. Okay. So it's very, you actually get a grasp of the topic once you solve gate questions. ESC questions, ISRO questions, they are, one-liner questions or one-step solution questions. So today we are going to take some 4 or 5 gate questions and then we will move to ISRO questions. Okay. So should we start? Should we start? Okay. Now, I hope you are able to see the question on the screen. Just take 20 seconds and try to understand what the question is saying. Try to understand the logic behind it. Try to make an approach in your mind what you are going to do with this question, and then we'll start the question. Just take 20 seconds, okay? And let me utilize this time to draw the diagram. Yes, Nitish, as I said, you can attend this session because it is heat transfer session. The syllabus of heat transfer in mechanical and chemical is same. So questions are also similar. In fact, I have taught heat transfer to chemical students, so I have seen the syllabus. It's almost same. Okay. So yes, you can attend the session. No problem. Okay. I hope I have given you enough time to understand the question. Okay. Now let us try to, you know, okay. Let us try to read out the question. The question is saying, I hope whatever I am writing is visible to you. Say yes or no if it is visible. Can you tell me if it is visible? Yes or no? Okay. So the question is saying a plain slab of thickness L. So the thickness is L. Okay, the thickness is L. This thickness is L. Okay, is heated with a fluid on one side P. So we have two sides of this slab. One is P, one is Q. On the P side, we are heating it with a fluid, and the and the other side Q is maintained at a constant temperature TQ. So TQ is given to be 25 degrees Celsius. 25 degree Celsius. Okay. TQ is given to be 25 degrees Celsius as shown in the figure. The fluid is at temperature. This fluid which is flowing is at temperature what? 45 degrees Celsius. And the surface heat transfer coefficient H is also given. H is also given. How much is H? H is 10 watt per meter square Kelvin. Okay. Now they are asking, tell us the temperature Tp. They are asking what? Tell us the temperature Tp. Okay, this temperature we should have to find out Tp. This is Tq, and the fluid that is flowing here is basically T infinite. Is that temperature T infinite? Okay. So what can you do? So very simple question. Very simple question. You see, what is this? This is T infinite. This is Tp. This is Tq. Right? What is the resistance here? Convection resistance. Convection resistance. What is the resistance here? Conduction resistance. What is conduction resistance? 1 upon HA. What is conduction resistance? L upon Ka. L upon Ka. So from Fourier's law of conduction, from Fourier's law of conduction, what can I write? From Fourier's law of conduction, what can I write? Q heat transfer is equals to, can I write PQ minus TP upon convection resistance, and it is also equal to TP minus T. I'm sorry, it is not TQ, it is T infinite. Okay, sorry, my bad. Upon R conduction, right? Simple. Now I can find out Q, then I can find out TP, but there is no need. I will directly use these two equations, and I will try to calculate TP. Okay, let us see. What is T infinite? T infinite is given to be 45. It is given to be what? 45 minus TP I need to find out. 1 upon H. What is H? How much is H? 10 into area. Then TP minus TQ is 25. Thickness is given to us. Thickness is given to us or not? Okay, this question has, I don't think it has given L, but you write it down. L is given in question. Okay, L is given in question. L is equals to, I will get it corrected. L is equals to 0.2 meter. I think it is 0.2 meter. It is given in question. There's a mistake typing here, or collecting the question somewhere. I'll get this figure out. Okay. So L is 0.02 upon conductivity is also shown in the figure. Conductivity, I think you will show in the question. You can see in the question, right? 2.5 into area. Now area and area gets cancelled, and when you solve this, you will get TP is equals to 33.89 degree Celsius. I hope it is clear. It is a very simple question. Usually gate standard is higher, but this type of question can be easily asked in any PSU. They will give you values that can easily cancel. You can calculate it without any calculator. Okay. So I hope it is clear. Yes or no? Nitish, are you able to understand it? Chalo. Let us move on to the next question. Now this question is again visible to you, I think on the screen. Just try to read out this question, take 20-25 seconds, and then we will start solving. Try to make an approach in your mind, what we are going to do with this question. Okay. Okay. So I hope you have read the question. Let us start solving it. What is the question telling you? What is the question telling you? Let us try to read out the question. Heat is generated uniformly in a long solid. You have a long solid cylindrical tube. You have a long solid cylindrical tube rod and with diameter 10 millimeter. Or heat is generated with the rate of 4 into 10 to the power 7 watt per meter cube. Okay, so Q generation is equals to small q dot generation into volume. Thermal conductivity is also given 25. Under steady state condition, the temperature difference between the center and the surface of the rod. What are they asking? Anyone? What are they asking? You see, this is the center of the rod. This is the center of the rod. X is equals to 0. And this is the surface. What? X is equals to capital R. Or let me write it not in terms of X, in fact R. So I can write here at the center R is equals to 0. Here at the surface R is equals to capital R. And if you have studied heat and mass transfer with me anywhere, because this is a problem session, so we are not going to go into derivation, but I have properly derived it. And we started with an assumption that at R is equals to 0, T is equals to T naught. T is equals to T naught. And at R is equals to capital R, T is equals to surface temperature. Okay. And we started with this and we derived it properly. And we have come up with two equations. What are the two equations? Let me write it. The two equations. The two equations were T minus T naught. T is the temperature at any R. Okay. T is the temperature at any R value. At any R. Okay. Is equals to minus Q dot generation minus Q dot generation 4K R square. So if you know the temperature at the center T naught, then you can find temperature at any value of R. Not at the surface, not at the center. Anywhere you want, you can calculate what is the temperature at any R, at any radius. Also, I have solved one more equation. What? T surface minus T naught is equals to Q dot generation by 4k r square, capital R square. So what are they asking? Read the question. They are asking the temperature difference between the center and the surface rod. That means they are asking basically T naught minus Ts. T naught minus Ts is equals to Q dot generation by 4k r square. You know everything. You know everything, don't you? What do you know? You know Q dot generation 4 into 10 to the power 7 into what is capital R? R, capital R is equals to 5 millimeter. Capital R is equals to 5 millimeter. So R into 10 to the power minus 3 a whole square upon 4 into what is thermal conductivity? 25. So if you solve this, you will get the answer to be 10 degree Celsius. 10 degree Celsius. The temperature difference between the center and the surface is 10 degree Celsius. 10 degree Celsius. That is your answer. Clear? Yes or no? Chalo. I hope it is clear. Let's move on to the next question. Okay. I hope it is visible to you, the question, right? I hope that the question is visible to you. Try to read out the question and then we'll start solving it. Okay. Okay. I hope you have read out the question. Let us try to understand what the question is saying. Okay. Chalo. The question is saying we have a 1 meter thick wall and the temperature distribution, how the temperature is changing in x direction. It is saying Tx is equals to C naught plus C1x plus C2 x square. Okay. Now C naught, C1 and C2 is given. C naught is basically 800 plus C1 is minus 250 minus 250 x and C2 is minus 40 x square. So this is my how the temperature is changing in x direction it is giving me. Clear? Now what are they asking? Thermal conductivity is given 50. I have written down the question And wall area is also given. Wall area is also given. What area? What area they are giving? They are giving this area. You see, this area they are giving me. This area is how much? 5 meter square. Okay, 5 meter square. Now there is a heat source also generating uniform volumetric heat at the rate of 500 watt per meter cube inside the wall. The rate of change of energy storage in the wall in kilowatt I need to find out. How the energy is stored in the system, that I need to find out. Okay. Now I know that you all remember the energy conservation. This is the basis of the Fourier's law as well. Energy conservation inside the wall or inside the slab. If I do, what can I write? Energy, that is whatever is going in, plus energy that is generated, plus energy that is going out is equals to change of energy in the system or the wall. Okay. So if I find out all three of them, energy in, energy generation, energy out, I will be able to find out the energy change in the system. Clear? Now, how do I find out energy in? What energy is going in? Heat energy. Okay. So Q dot in, okay, Q dot in is equals to, Q dot in is equals to minus Ka dt by dx. Are entering where it is entering. Look, here x is equals to 0, here x is equals to L. So energy is entering here, energy in. Energy is going out from here at x is equals to L. And energy is generated inside the slab. Okay. So when I talk about in, I have to take x is equals to 0. Okay. Chalo. Minus k is how much? 50. Area is how much? 5. Now if I differentiate dt temperature, if I differentiate with respect to x, what will I get with respect to x? Minus 250 minus 80x. Okay. But I have to take it at x is equals to 0. So when I put x is equals to 0, this term will go to 0. So this is something you will get 50 into 5, 250, and then 250, 625, 00 watt. This is my Q dot in. Okay. What about Q dot out? So Q dot, let us take generation first. How much is generated? Q dot generation into, this is what? Watt per meter cube. Now I multiply it by volume, so I will get meter cube. Okay. So this is 500 into area into length. Area, this is what? Area into length. Area is how much? 5 into 1. 5 into 1. So this is somewhere is 2500 watts. Right? Now let us try to go ahead. Just 1 second. Let me try if I can take the whole thing. Okay. Now what I need to find out? I need to find out Q dot out. Again, what will I do? Minus KA minus KA. In fact, let me put this side. Okay, anyway, let us try to solve it. Okay. So Q dot out I need to find out. It will be equal to minus KA dt by dx at what? X is equals to L. Okay. So now what will I do? Same thing I'll do. Minus 50 into 5. And when I differentiate it, I'll get minus 250 minus 80x. And here x is equals to L. Here x is equals to M. And what is L? L is equals to 1 meter. So I can write x is equals to 1 meter. X I will replace by 1. So when I do that, I will get minus 50 into 5 into 250 minus 80 is 170. I think, no, it is add 250 minus 80, it is minus 330. And when you solve it, you will get Q dot out is equals to now what will I do? I'll substitute Q in here, Q generation here, and this here, and I will find out. So change of energy inside the wall is equals to what? 62500 plus 2500 plus 82500, and the answer that you are going to get is this is minus, sorry, minus. Okay, it will be minus, that is my fault. Okay, of the system is equals to 17500 watts, or I can say it is 17.5 kilowatt. Okay, so this is your answer. This is your answer. Okay, now we are going to move on to our ISRO portion. Is it clear? I hope it is clear. Okay, so let us move on to the ISRO solutions. Okay, so I hope the question is visible to you. Now, let us take 20 seconds to read out the question very quickly and then we'll start solving it. Okay. It should not take more than 20 to 25 seconds to read out the question because it is a ISRO question. Okay. Clear? Okay. Let's try to read the question. The external surface of the wall, we have a wall, height is 3 meter, width is 5 meters, and the thickness, this thickness is 0.5 meter. Heat loss is happening of 150 watts from the room is measured. So we have a wall, this side we have a room. Okay, and heat is getting lost from the room and going through the wall and going outside. Okay, now the outside the outside of the wall is at 2 degrees Celsius. Okay, now the thermal conductivity of the wall is given 1 watt per meter Kelvin. They are asking what is the inner wall temperature. Inner wall T1 I need to find out. T1 I need to find out this T1. Very simple question, I guess. What is the question? From Fourier's law, I can say Q dot conduction is equals to K A T1 minus T2 upon length, thickness. Okay. K is 1, area is 3 into 5. T1 I don't know. T2 I need to find out. Length or thickness is 0.5 and this is 150. This is 150. Okay. They are asking in Kelvin. They are asking in Kelvin. Okay. So once you solve this, you will get T1 is equals to 7 degrees Celsius or 280 Kelvin. I don't think you can get a simpler question than this. Okay. Clear? Yes or no? Hello. Let's very quickly move on to the next question. I hope you are solving with me. So it's very important that you solve it with me. Okay. So let's try to go with the next question. Ratio of convective mass transfer to the mass diffusion rate is called. Anyone? Anyone? Can you tell me what is the ratio of convective mass transfer to mass diffusion? Now, this is something that Nitish can tell me. I hope you are studying mass transfer, so you can tell me what is the ratio of convective mass transfer to mass diffusion. Okay. Now, before we move ahead, we need to understand two things: that whatever relationship, whatever dimensionless numbers that we have in heat transfer, there is an analogous number that represents something similar in mass transfer. Okay, so I hope that you know that what is a Nusselt number. What is Nusselt number? Can anyone tell me what is Nusselt number? Nusselt number is convective heat transfer upon conductive heat transfer. Okay, and we denote it by H LC by K. Okay. A similar number in mass transfer we have, which is called a Sherwood number. What do we call Sherwood number? Now, what it represents? It represents convective mass transfer divided by mass diffusivity. Mass diffusivity. Okay. It is showed by mass transfer coefficient. Like we have heat transfer coefficient, convective heat transfer coefficient in heat transfer. You have mass transfer coefficient in mass transfer, HLC by D. Okay. Now what is Smith number? Yes, HLC by K. Very very nice. No, not Smith. That is Sherwood number. Okay. Now similarly, we have one more number B. I hope you are all aware of Prandtl number. What is Prandtl number? What is Prandtl number? Momentum diffusivity upon thermal diffusivity. How thick is your thermal boundary layer compared to your mass boundary layer, momentum boundary layer? Okay. Thermal diffusivity. How do you show this? Kinematic viscosity by alpha. Now, analogous to this, we have Smith number. We have Smith number. Okay, Smith number is momentum diffusivity will remain same. Momentum diffusivity, but instead of thermal diffusivity, we will have mass diffusivity. Okay, so kinematic viscosity upon mass diffusivity. Clear? Also, Rayleigh number, I hope you all know. What is Rayleigh number? Grashoff's into Prandtl number. So, what is the right answer? What is the right answer? Sherwood number is the right answer. Okay. Now let us move on to the next question. Okay. Now they are asking Lewis number. Tell us what is Lewis number. Question. Lewis number. Anyone? Lewis number. Can you tell me what is Lewis number? Yes, A is the right answer. Anyone? Lewis number. Lewis number is defined as Smith number upon Prandtl number. So what is Smith number? Momentum diffusivity upon mass diffusivity. What is Prandtl number? Momentum diffusivity upon thermal diffusivity. Right? So if you cancel this, it is alpha by T. So basically the answer is Smith number by Prandtl number. So B is the right answer. Clear? Yes, that is correct. Vidyarthi. Very nice. Sure. Let us move on to the next question. Okay. I hope it is visible to you. They're asking Prandtl number. We have just seen what is Prandtl number. They are asking that temperature is a gas is there. Temperature is 27. I'm sorry. Temperature is 27. Pressure is equals to 10 to the power 5 Pascal. Kinematic viscosity is 1.8 into 10 to the power minus 5 meter square per second. Specific heat capacity Cp is 700 kilojoule per kg Kelvin. Thermal conductivity K is equals to 0.02 watt per meter Kelvin, and take gas constant as 300 joule per kg Kelvin. They are asking calculate Prandtl number. Very simple. Prandtl number, just now we have seen, is kinematic viscosity upon thermal diffusivity. Now this is directly given to you. How can you calculate thermal diffusivity? 1.8 into 10 to the power minus 5. Okay. Now thermal diffusivity is defined as K upon rho Cp, right? So I can write K is how much? 0.02. Rho I don't know. Cp I know again. Cp is 700. How do I calculate rho? भैया it is a gas. क्या है ये? गैस है. अगर गैस है तो हम आइडल गैस इक्वेशन लगा सकते हैं. तो आइडल गैस इक्वेशन लगा दो. PV is equals to MRT or P is equals to rho RT. Rho is equals to P upon RT. Pressure is 10 to the power 5. R is 300. Temperature is 300 again. Right? 27 degrees Celsius is what? 300. Clear? So when you solve this, you will get 1.11 kg per meter cube. You will write 1.11 here. And when you solve this, you will get how much? 0.7. 0.7. Okay? Clear? Very nice. Let us move on to the next question. Now, just try to read it for 20 seconds, and then we'll try to solve it. Right? Okay, let us see what the question is saying. For heat transfer across a composite slab with materials having different thermal conductivity K1 and K2, they are different. Okay. Temperature is, so study the following statement. Temperature is all continuous always. Temperature gradient is not continuous. Heat flow is not continuous. तो सबसे पहले तो we all know one thing. We are very sure of one thing. What? Heat transfer is always steady and continuous. Q. When there is a heat conduction between two slabs, heat transfer is always, or conduction heat transfer is always continuous and constant. Okay. So C is not correct. C is statement third. I can conclude one thing, that is statement third is incorrect. Okay. So D option though is not correct. Let us try to understand it further. Now tell me one thing. If I say Fourier's law of conduction, so Q dot conduction is equals to minus Ka dt by dx, right? Minus K dt by dx. Now if I take dt is equals to Q dot conduction by Ka into dx. Okay. Now Q dot conduction is same, thermal conductivity and area. Okay. So how the temperature, if I integrate this, okay, so I can say temperature is a linear function, of x, right? By this equation, because this is kind of a constant. So temperature, I can conclude with this, that temperature is a linear function with respect to x, and therefore it is continuous. Okay, and continuous, let me write, and continuous. Continuous कब नहीं होगा? When there is a C. No. Wait. Okay. Continuous कब नहीं होगा? When the contact is not perfect. Then there is a high fluctuation in the temperature. Okay? जब दोनों के बीच में जो contact है, जब वो perfect नहीं होगा, then temperature is going to vary. Okay? So temperature, अगर the contact between two slabs is perfect, which is, I think, they are given also. No, they have not given, but anyway, if they give that the contact between the two slabs is not perfect, or there is a contact resistance, then the temperature will not be continuous. Okay, so that is means statement first is correct. Okay, now let us talk about the second statement. So what does second statement telling me? Temperature gradient, right? Temperature, what is temperature gradient? Dt by dx. So from the same equation, if I say dt by dx is inversely proportional to k, right? Agar conductivity is higher, if the conductivity is higher, for example, if conductivity is higher, then dt by dx is lower. If conductivity is lower, then dt by dx is higher. Okay, and therefore, because the thermal conductivities are different, dt by dx is not continuous. So statement second is also correct. So basically, statement 1 and statement 2, they are correct. Okay. Yes, B is correct. Very nice. Chalo, let's move on to the next question. Okay, yeah. In this question, there has been some mistake. I tried to solve it, but maybe some data is missing or something. So let us not go with this question. You can mark it down. I'll ask them to remove this probably. Okay. Let us try to move on to the next question. Yes. Very simple question. Very, very, very simple question. Can you tell me what is the right answer? Question. Critical thickness of insulation yields. Critical thickness of insulation. Critical thickness of insulation. The simple funda of critical thickness of insulation is that at the critical thickness of insulation, let us say RC, thermal resistance is maximum or minimum? Thermal resistance is maximum or minimum? And heat transfer. Tell me very quickly, thermal resistance is maximum or minimum? Thermal resistance is minimum. No, not correct, Vidyarthi. And heat transfer is maximum. Okay, you see this type of diagram is drawn. This is your radius. If you have a pipe like this, and this is how your radius is increasing. So if this is your radius, this is your heat transfer, then some kind of graph is formed like this. And here, this is called as critical radius, where we find maximum heat transfer. So at R, less, if your actual R is less than RC, then what will happen? Heat transfer will increase. Heat transfer will go in this direction. Okay. For example, let us see. Your critical radius is 100 millimeters. And now you have a pipe with radius, let us say 60 millimeter. Now, if you are adding insulation, heat transfer is going to increase. And when it will reach, you are increasing the thickness, and when R will reach to 100 millimeter, which is also equal to critical radius, Q will be equal to Q max. And still, if you keep increasing the radius, so for example, R is 110 millimeter. So now Q will start decreasing. Q will start decreasing. Okay. So maximum heat transfer rate from the pipe. Very correct. Yes. Okay. Hello. Next question. Question. It is required to insulate a kitchen oven with a cork board. Cork board is what? It is insulating material. So conductivity is equal to 0.043 watt per meter Kelvin. So that, not wo that, so that the heat losses from the oven does not exceed. So Q maximum should be what? 400 watt per meter square. Yani ki it is what? It is per unit area. Okay. When the inner surface of the oven, inner surface, inside temperature is what? 225 degrees Celsius, and outside surface is 40 degrees Celsius. The thickness of insulation required is nearly. So the maximum heat transfer is 400. उससे ज्यादा आप नहीं अलाउ कर सकते. You cannot allow more than 400. So ये maximum heat transfer कितने पे होगा? RC पे. So at critical radius, Q is equals to Q max. Okay, Q is equals to Q max. Now let us calculate RC. So can you calculate RC? RC for a cylinder. How do you calculate RC for a cylindrical rod? Cylindrical rod, it is K is equals to H naught. Can you tell me what is RC for a sphere? 2K upon H naught. Okay. So here they are asking the thickness of the insulation. Okay. So we can also do it like this. How can we do it? By Q dot is equals to Ka T1 minus T2 by L. So this is thickness that we need to find out. Okay. L is equals to K कितना है? K is 0.043, or 1 second, let me write it like this. Q by A is equals to K T1 minus T2 by L. Now I can find out L from here, which is 0.043. T1 is how much? 225 minus 40 upon 400. Okay. So when you solve this, L is equals to 0.01988 meter, or how they are asking centimeters. So 1.98 centimeter. The most correct answer is 2 centimeter. Okay. Sure, we can connect later for this, but just briefly, if you ask me, I would say if you know what is your waiting list, then it is you will get a better idea if you will get selected or not. Because if 800 vacancies are there and 2000 people have, like they are shortlisted, so it's very difficult if you are in the waiting list. Hello. We can also connect later. So what are the details? Next question. Okay. Can you read the question? If two ends of rod of length L and radius are made of same material, are kept at the same temperature difference, which of the following rods conduct most heat per unit time? So you have two rods. Okay. Okay. So you have two rods. Okay. जिनकी length और R we can change, but they are maintained. They are made up of same material. एक ही material की बनी हुई है. So what we are doing? We are only playing with length and radius, and we have to see that if the material remains constant, if the temperature difference remains constant, which one will give you the maximum heat transfer? Which one will give you the maximum heat transfer? Okay. So what is Q? From Fourier's law of conduction, Q is equals to minus Ka dt by dx. Okay. And you can also, it is proportional to if conductivity is same. If conductivity is same and temperature difference is same, then it is proportional to area upon thickness dx. Let us say L, length. And for a cylinder, area is proportional to r square by L. So we just have to play with this. Let us see. A option is saying L is equals to 50 centimeter and radius is equals to 1 centimeter. So Q is equals to 1 square by 50. Okay. B is L is equals to 2 centimeter. R is equals to 0.5 centimeter. So Q is equals to how much? 2 square by 0.5. Okay. Next. C. L is equals to 100 centimeter. R is equals to 2 centimeter. So Q is equals to 100 square. 1 second. 2 square. 1 second. 1 second. This will be 0.5 square by 2. And this is 2 square by 100. D. 3 centimeter. Radius is equals to 1 centimeter. So Q is equals to 1 square by 3. So you can calculate individually. This will come to be 0.02. This will come to be 0.125. This is 0.04 and this is 0.333. So which one is maximum? Which one is maximum? D is maximum, of course. Okay. The right option is D. Okay, already marked. Chal, next question. The transmission of heat by molecular collision. Anyone? Just take 20 seconds and tell me what is the right answer. Yes, very nice. Conduction. Correct. So you have to understand one thing, that when conduction happens, if you have studied HMT with me anywhere, then I have explained it in very detail. Conduction can happen in solid, liquid or gases. Okay. So when it happens in solid, it happens because of two reasons. What are the two reasons? Molecular lattice, vibration, energy transfer, and free electron energy transfer. Okay. Then it can also happen in liquids. Liquids, it happens because of two reasons. What are the two reasons? Molecular collision, that is actually given in question. Molecular collision and diffusion of heat. Right? Next, in gases, the only reason that causes the conduction heat transfer is molecular collision. Okay, the right answer is conduction. Okay, so next. There are few conditions that are, that tells you that conduction is happening, that tells you convection is happening. So for example, in conduction, physical contact is necessary. Okay, physical contact, it happens inside the body, convection, it happens at the surface, okay. And second thing is that it requires at least one fluid. So either could be a fluid or a solid fluid. Radiation, of course, we know that it happens because of electromagnetic waves. Okay, there is no material medium that is required, right? Chalo, next question. Very quickly read out this question and we will 20 seconds you take, and then we will start solving it. Okay. So the question is telling me that we have a bar of copper जिसकी लेंथ जो है 75 सेंटीमीटर है. Then we have a steel bar whose length is 125 centimeter length, and they are joined together end to end. Both the bars are having same diameter. So area is same, diameter is 2 centimeter. Now the free end of, so one side of copper is maintained at 100 degrees Celsius, and the extreme side of steel is maintained at 0 degrees Celsius. The curved surfaces of the bar are thermally insulated. So these things, so this is thermally insulated. So basically the heat transfer is not in radial direction. Heat transfer is only in this horizontal x direction. Okay, only in this direction heat transfer is happening. Okay, conductivity of copper is given, case U is given 400 watt per meter Kelvin. Conductivity of steel is given 50 watt per meter Kelvin. Okay, they are asking calculate the temperature between the junction. Temperature at this junction I need to find out. Here, what is the temperature? Let us say this is T. Let us say this is T. Say this is T1. Say this is T2. Right? Very simple question, isn't it? Okay. How to solve this? भाई Fourier's law of conduction ये बता रहा है कि Q dot conduction is equals to in copper क्योंकि कंडक्शन तो यूनिफॉर्म ही है, ठीक है ना, इन स्टील, राइट. सो कैन आई राइट T1 minus T upon K L by Ka. Can write this. Similarly, I can write T minus T2 upon L by K of steel. This is copper. This is copper. This is steel of area. Now area is same. Diameter is same. Area is same. Right? So everything is known to me. T1 is 100 minus T. Length is 75. So everything is known to me. I just need to find out T. Everything is known to me. Just need to find out T. I think you will be able to calculate it. Okay. So T2, so T is equals to 93 degree Celsius. Degree Celsius में they are asking. Okay. चलो. Hope this is clear. Let us move on to the next question. Okay. क्या कह रहे हैं ये? Just try to read out the question, then we'll see what we can do here. Okay. Okay. So first thing they are giving, there are three metal walls of same cross sectional area. So area is same. I can say A1 is equals to A2 is equals to A3 is equals to A. And thermal conductivity is K1, K2, K3 is equals to 1 is to 2 is to 4. Heat transfer rate is given, conduction is equals to 6000 kilojoule per hour. There is a slight mistake in the question. It is kilojoule per hour. Okay. Now wall thickness is also same. L1 is equals to L2 is equals to L3 is equals to L. Now I need to find out the relationship between T1, delta T2, delta T3. This relationship I need to find out. Okay. So again I will apply the Fourier's law. Q is equals to Ka delta T by L. Now minus I have not put because delta T here is T1 minus T2. Okay. This is T1 minus, that is why I am not assuming minus here. Simple. Okay. Now, because you see, if I say Q is constant, length is also constant and area is also constant. So, K into delta T is equals to constant. Yes, very nice. Okay. So, what can I do? I can say K1 delta T1 is equals to K2 delta T2. Although it can be directly solved by a logic, that if K is directly proportional, is inversely proportional to temperature difference, then answer you can logically, you can answer it by the logic, simple logic. Okay. So thermal conductivity is minimum for the first rod. So temperature difference will be maximum for the first rod. Simple. Similarly, thermal conductivity is maximum for the third rod. So temperature difference will be minimum for the third rod. So you can do that. Okay. That is correct. Yes. Okay. Chalo. So can I say delta T 1 is equals to delta T2 is equals to K2 by K1. So K2 is how much? 2 by 1. I can do this. Okay. So I can say it is 2 is to 1. Similarly, K2 delta T2 is equals to K3 delta T3. So K delta T2 by this is equals to K3 by K2. Now K3 is how much? 4, and this is what? 2, right? So this I can say 2 is to 1. 2 is to 1. Okay. So the first relationship is telling me, this is telling me that temperature difference in the first rod and second rod is the ratio of 2 is to 1. And the second ratio is telling me temperature difference between second and third rod is in the ratio of 2 is to 1. Okay. So just uniformity, because here delta 2 is representing 2. Here delta 2 is representing 1. So let me make it delta 2 uniform. So can I say it is also equal to delta T1 by delta T2 is equals to 4 is to 2. Same thing. It will be 2 is to 1. So now I can compare C and B. So I can compare C and B, and I can say delta T1, delta T2, delta T3, 4 is to 2 is to 1 is also equal to 1 is to 1 by 2 is to 1 by 4. So that is correct. Okay. So let's move on to the next question. Next question. It is proposed to coat a 1 millimeter diameter wire. Try to read the question. Till that I will draw a diagram. Okay. Take 20 seconds. Try to read the question. I will draw a diagram quickly. Okay. So they are saying, okay. So they are saying that you have a wire, you have a 1 millimeter wire, and you have to coat it. Okay. You have to do a thickness insulation coating to increase the heat transfer with air. You want to increase the heat transfer. Okay. So I need to coat it. When I have to coat it, I'll do it with a different color. I'll start my coating. And if I start coating, what will happen? The radius will increase. the radius will okay. So this is my enamel coating. I'm coating this with the insulation. This wire I am coating. Now they are asking, I have to maximize the heat transfer. I have to maximize the heat transfer. Okay. And heat transfer coefficient is given as H is equals to 100 watt per meter square Kelvin. And the thermal conductivity of this enamel paint is 0.1 watt per meter square. They are asking what is the optimum thickness of this insulation to increase the heat transfer. Calculate this thickness. I need to find out this thickness. Okay. What is this thickness? We all know that at critical radius of insulation, at critical radius, of insulation, what happens? RC is equals to K by H naught. K is how much? 0.1. This is how much? 100. So you will get 1 millimeter. So what you can increase the radius up to 1 millimeter, and at 1 millimeter the heat transfer will be maximum. But if you increase the radius above 1 millimeter, then the heat transfer will start reducing. Okay, but you want to maximize the heat transfer. So already, so you see the maximum radius that you can go is 1 millimeter. Now already you have 0.5 millimeter. So how much thickness you can add? So optimum thickness is equals to RC minus R. So thickness is equals to RC is how much? 1. R is how much? 0.5. So the answer is 0.5 millimeter. This is the right answer. Thickness, they are asking thickness. Optimum thickness of enamel paint. They are not asking critical radius, Vidyarthi. They are asking thickness. Okay. So very, very cautiously you have to read the question. YouTube पर short view है class का. What do you mean? Are you watching on mobile or something? But I think you would be able to see what I am writing, isn't it? What I am writing is clear or not? Whatever I am writing here, is it clear? Because I am writing, I'm writing in big fonts. I don't think. Okay, okay. Chalo. Let's move on to the next question. Something similar? Something similar? Let's try to solve this. Same question. For a current, again you have a wire of 20 millimeter and it is exposed to air. Maximum heat dissipation occurs when the thickness of insulation is. So you have a wire You want to insulate it. At what thickness of that insulation? At what thickness of that insulation the heat transfer will be maximum? So again, thickness of insulation will be critical radius minus actual radius. Okay, actual radius is how much? Actual radius is 10 millimeter. Already 10 millimeter is there. RC I need to calculate K of insulation upon H naught. K of insulation is 0.5. H naught is 20. Okay. So when you solve this, you can also multiply it by 1,000 is 25 millimeter. So basically thickness is equals to 25 minus 10 is equals to 15 millimeter. 15 millimeter. Okay. Now thickness of insulation should be 15. If they ask radius, critical radius of insulation, then it is. So you have to distinguish, you should be able to distinguish between thickness and critical radius. Okay. So thickness, it is not given, so none of the above. Okay, chalo. Next. Okay, the question looks really big. Okay, now the question looks, yes, 15 millimeter is the right answer. Next question. The question looks really big, but it is not. If you just read out the question, it is not very difficult. They are asking critical insulation radius. If you see the last line, they are asking critical insulation radius. Critical insulation radius. So this time they are asking radius, not thickness. Okay, and we all know it is a cross section through a pipe. It is a cross section through a pipe. That means it is a pipe or a cylinder. And we know how to calculate critical radius for a cylinder, right? K of insulation upon H naught. Now K of insulation is given. If you see the figure, insulation is given 0.06. And H naught, outside H naught is given 10. Outside H naught is given 10. Always outside you are going to take, okay? And it is equals to 6 millimeter. Very simple question. The question seems to be difficult, seems to be very long, but once you read it and you figure out what you have to calculate, it is very simple. 6 millimeter, and the answer is 6 millimeter. Okay, chalo. Next question. Okay, a furnace wall is constructed as shown in the figure. The interface temperature T I need to find out. Interface temperature T. I hope that you are able to see the question and you are able to see the data as well. Okay, you are able to see the data as well. Try to just read the question, figure out the data, and then very quickly we will solve it. K1 is equals to 3 watt per meter Kelvin. K2 is equals to 0.3. And this is 0.3. This is also 0.3. It is 120 degrees Celsius. And the fluid that is flowing here is at 40 degrees Celsius. Here it is 1000 degrees Celsius. They are asking calculate that, let us say this is T1. At the interface we have T2 and this is T3. I need to find out T2 or intermediate temperature. Okay, very simple question. So Fourier's law we are going to apply. Fourier's law, right? T1 minus T2 L by Ka, L1 by K1 A is equals to T2 minus T3 L2, this is L2, this is L1, okay, by K2A. Now area and area will get cancelled. T1 is 1000, T2 I need to find out. This is 0.3, this is 3, T2 I need to find out. This is 120, this is 0.3, this is 0.3. So this cancel, this will be 0.1, and you can calculate T2 is equals to 920 degrees Celsius. Very simple question. Okay. Now let us move on to the last question for today. Something similar. So let us do it together. Okay. So what do we have? We have this, wall. One, two. Okay. And this is L1. This is L1. This is L2. Okay. Now L1 is given in question as 0.3. L2 is given as 0.15. Okay. Also, some fluid is flowing here. You see, some fluid is flowing here. Convection is happening. Some fluid is flowing here as well. So here, fluid temperature is equals to 20 degrees Celsius and HI is equals to 20 watt per meter square Kelvin. Right? This side, the fluid that is flowing T infinite out is equals to how much? Minus 2 degrees Celsius, and H out is equals to 50 watt per meter square Kelvin. Clear? What else is given? K1 is given. K1 is given as 20 watt per meter Kelvin. K2 is given as 50. So this is the data they have given. They have given assuming negligible contact resistance between wall surfaces. The interface temperature, I need to find out this temperature T. This temperature T I need to find out. Right? So very simple. I don't think there is anything in this. If you want to draw, let us say we have T1 here, T2 here. So I can draw a circuit diagram, right? How can I draw a circuit diagram? Okay. This is T infinite 1. Convection resistance R convection 1, which is 1 upon HI AI, right? Here we have T1, conduction resistance L1 upon K1A. Here we have T. This is again conduction resistance L2 upon K2A. And this is my T2. And here we have R convection outside. 1 upon H out, A out. And here we have T infinite 2. Okay. So what will I do? Again, I will apply Fourier's law of conduction. Fourier's law of conduction. So heat transfer is basically uniform. Okay. I can say that T infinite I minus T upon R convection 1 plus R conduction 1 is equals to T minus T infinite out R conduction 2 plus R convection out. I can say that, yes. Chalo, if I can say that, let me put the values. This is 20 degree, right? Yes. 20 minus T. Convection is how much? 1 upon H is 20 into area plus L1 is 0.3, K1 is 20 into area is equals to T minus 2 upon L2. L2 is 0.15 upon K2 is 50 into area plus 1 upon H not 50 into area. 50 into area. Right? So area will get cancelled. Area is same. And you can solve this. You can solve this. You will get, I am not very sure that you will get 0.065 equals to T plus 2 upon 0.023. So T you can calculate 3.746 degree Celsius. This is, I think, 3.76 is given. So this is your right answer. Okay. I hope it is clear. So this was the last question of ISRO. Okay. Now we will meet on, I think, 9th, or we'll start pins gate questions. Okay. So this is a very good way of practicing your questions, revising the concepts, because you can't keep reading the same thing again and again. So let us meet on 9th and we will start fins and unsteady state also. Unsteady state conduction and fins. Okay. I'll meet you there. I hope that you enjoyed the session. Thank you. You can ask the doubt in the group as well. Whatever the doubt you have, you can ask in the group. Okay. Chalo. Thank you very much.